Hi, I'm Shannon Seaver, and today we're looking at part 2 of basic set concepts. Today we're going to look at how to apply set notation to natural numbers. We're going to determine the set's cardinal number, and we're going to recognize equivalent sets. First of all, I would like to talk about what natural numbers are. A set of natural numbers are counting numbers that start with the number 1. 1, 2, 3, 4, 5, and so on. Notice it has an infinite number there. So it can go on to infinity. Next, I would like to look at representing sets of natural numbers. We're going to express each of these sets in the roster method. Set A is a set of natural numbers less than 5. Well, to write this in roster method, we know that natural numbers start with the number 1, and we want to keep going for all the numbers that are less than 5. That does not include 5. It's just less than it. So 1, 2, 3, 4. Set B is a set of natural numbers greater than or equal to 25. So starting at the number 25, we have 25, 26, 27, and we can put ... indicating that it goes on forever. On number 3, we have x such that x is a natural number and x is even. So we are going to write even numbers. E equals, starting with 2, 2, 4, 6, 8, and so on. Now I'd like you to pause the video and remember, first of all, I'm going to change this to odd, how to write this in roster method. Try this on your own and then turn back on the camera and see if you're right. Now take a moment to check your work. Did you get the same thing I did? Set 2 is a little tricky. Notice it said greater than. It didn't say greater than or equal to, so we don't start with the number 14, we start with 15 on this one. Now let's look at these sets using the roster method. X such that x is a natural number and it's less than or equal to 100. So remember that we're starting with the number 1 here. But we need to make sure it goes all the way up to 100, and that would be our final spot. On the next one, we are starting with 70 instead of 1. So we'll have 70, 71, and so on up till, now notice it doesn't have an equal sign here, so we want to take it up to 99. Cardinality. A cardinal number is the number of distinct elements in a set. Sometimes we are asked what the cardinality of a set is. So let's look at these following sets. How many elements are in A? Well, we have 4 elements in A. Now, if we had written A as in this set, notice that 11 is mentioned twice. Well, we're only going to count it the first time. So anytime you see a repeat, don't count the repeated number. We still only have 4 elements. On set B, we have 1 element. Don't let that number 0 confuse you. 0 is still an element and should be counted. Set C, notice that we start with 13 and end with 23. If you're to use your fingers to count these, if you start at 13, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, and then 23, we have 11 elements in that set. On the last one, we have an empty set. That means we have no elements, so the cardinality of that set would be 0. I'd like to talk about equivalent sets now. Remember, equivalent, well, you don't know this yet actually, but equivalent is the number of elements in a set. It doesn't mean it's an equal set. We'll talk about that later. But equivalent, we're just looking at the cardinalities of the set. So, and they also should have one-to-one correspondence. Let's look at these two sets and write them in roster method to see if they have the same cardinality. So in this case, we have vowels. We have A, E, I, O, and U. Set B, we have, starting with 3, we have an equal sign there, so, and greater than an equal, or less than an equal, so we'll start with 3, 4, 5, up through 7. Now let's see if they have a one-to-one correspondence. They should only match up to one item each. And yes, they do. So this set is equivalent, not equal, equivalent. A finite set is a number of countable numbers of elements. It's a set with where it has an ending. An infinite set is a set that never ends. So if you look at these two sets, they pretty much say the same thing. The difference is this dot, dot, dot. This one goes on forever. So this is an infinite set. This one ends at 5. It doesn't go on, so this is a finite set. Another symbol for infinite you may have seen before is this sideways 8. That's an infinite symbol. Also, you might see a squiggly N. That is also an infinite symbol for infinity. And here, what I'm just trying to say is that the smallest set of infinite numbers is the squiggly N sub 0 is less than the next size of infinite numbers, 1. You may see this a little bit in your textbook. I'd like to talk about equal sets now. An equal set is when set in A and B have exactly the same elements. Here we have an example of equal sets. Although they're not in the same order, they have the same elements in it. 4, 8, 9, 4, 8, 9. The second one is not equal because we also now have an empty set included in the set. So those two sets are not equal. So in summary, you learned how to apply set notations with natural numbers. We determined the set's cardinal number, or the number of elements in the set. We talked about infinite and finite sets. And we recognized equivalent versus equal sets. Remember, equivalent is the number of elements. And equal have the same exact elements. This concludes this video.